Okay, this is Unit 8, Targets 3 and 4 homework, number 19. Trying to figure out where the orthocenter is and where at compared to the triangle it is. The orthocenter is going to be outside the triangle because the triangle is obtuse, but we're not too worried about the fact that you know where all the things are. We do want you to be able to find them on a graph using their properties. So for an orthocenter, the orthocenter comes from the altitudes, and we need you to know the altitudes are drawn from a vertex perpendicular to the opposite side of the triangle, or perpendicular to the line that contains the opposite side of the triangle. For example, side MN, if you try to draw an altitude from L to MN, it's not going to hit on MN, but it will hit the line containing MN. So there's the line containing MN. The altitude would go from L to that line. I'm going to make my altitudes solid. And maybe even a little bit bigger to make it easier to see. So there's one altitude, which means that it forms a right angle. So drawn from L through the line containing MN. That one was easiest to do because of the vertical and horizontal line. For the rest of them, I'm going to have to find the slopes. So for the slope of LM, I can either calculate with the slope formula or I can count on the graph. It looks like I'm going down 4 and over 3, so negative 4/3 is the slope of LM. If I try to get a line and extend that out a little bit more, that would look like that. I need to extend that so I can see where to draw my altitude from point N. And my altitude then for this one from vertex N is going to have a slope of positive 3/4 because that's the perpendicular slope from segment LM. So we did positive instead of negative and 3/4 instead of 4/3. So from N, I need to graph a slope of 3/4. So I can go down 3 and left 4, down 3 and left 4, and then make that line. And it will make that line solid and easier to see. Right, so that is an altitude drawn to the side containing LM. And so I can see that the two altitudes intersect, it looks like at negative 5, 0. And so that's going to be your orthocenter. Unless instructed, you don't need to draw all three altitudes because, like I said, if all three lines are going to intersect at the same point, then when I find the intersection of two of the lines, that's going to be the same point as where the third line intersects. But just in case you want to see the process again, I'll go ahead and do the third side. I think I'll use pink. Actually, I think I'll use blue because I know I have a blue line set up. So I need to find the slope of LN because LN is going to be across from vertex M, and I have not used vertex M yet. So LN, slope of LN is, let's see, down 1, 2, 3, 4, and over 8. So it really is a slope of down 4 over 8, or negative 1/2. So it's pretty nice to work with. That means my altitude from M has a slope equaling positive 2. So from M, I can go up 2 over 1. That gets me my altitude. And if I want to extend that line, I can do so. Using that same slope. And so I can just verify that it does in fact intersect at negative 5, 0.